Hello dear students, this is Vijay Lakshmi. Welcome to Winma's YouTube channel. Here in this session we will discuss the concept continuity and differentiability for second PUC. Here this YouTube channel helping students across Karnataka to excel in their PUC board exam and competitive exam. Here in this session we have to discuss the continuity and differentiability concept. Here already we studied the concept differentiability, and based on that differentiability we already discussed some basic inverse trigonometric differentiation function and implicit functions. Here the exponential function with a positive base b is greater than 1 is the function of the form y is equals to f of x is equals to bx. Here we can discuss of the form y is equals to b to the power x. Here, the f of x be of the form b to the power x. Okay. Now, the graph of y to the power 10 to the power x. Okay. The graph of y is equals to 10 to the power x is given by in the figure. Okay. We can see the figure here. Let I will consider the equation y is equals to 10 to the power x. Here, 10 denotes the base of that function, base to the power x. Here, x is vary. Okay, here x varies their values. It advises that the reader plots this graph for a particular values of base like 2, 3, and 4. Here, I am taking y to the power y is equals to 10 to the power x. Okay, then we have the graph of like this. Again, similarly, y is equals to, here the graph denotes the y is equals to x. That is, there is a tangent line. Okay, here while taking y is equals to x square, we have like this. Similarly, for all the values of the form x, y is equals to x, y is equals to x square, y equals to x cube, y is equals to x to the power 4. We already learned these type of the differentiation problems. Here we have of the form to the power x. Here base be any constant value. Okay. Here base be any constant values we have taken. Following are some of the salient features of the exponential functions. Okay, here of the form. Okay, the function of the form y is equals to f of x is equals to b to the power x of the form functions are called it as a exponential functions. These exponential having some salient features or some characteristics they have. The first one is domain of the exponential function in R, the set of all real numbers. Okay, here domain of the exponential function is real number, then it containing the set of all real numbers. The second point, range of the exponential function is the set of all positive real numbers. Okay, here the range of the all the exponential function. Here, the base is positive number, then the exponential should be positive only. Therefore, we can say the range of the exponential function is always the positive real numbers. Then the point 0, comma 1 is always on the graph of the exponential function. This is a restatement of the fact that b is equals to b to the power 0. Here I can take b to the power 0. Okay, I can take b to the power 0 is equals to 1. Always anything to the power 0 is 1. Okay, that's for always the b values tends to greater than 1. Whatever the values we have taken here, the b value must be from 1 to any real number. Okay, now let's just exponential function is ever increasing. Exponential function is always increasing function. That is, as we move from left to right, the graph rises above. Okay, here we have to consider the one example, or that is, I have one example, that is x square. Now I am taking the value 1 square. 1 square is equals to 1 only. Now I can consider 2 square. 2 square is 4. Now 2 cube, it is 8. Okay. Therefore, we can say exponential function is ever increasing. Okay. It is always increasing. Then as we move from left to right. Again, for every large negative values of x, the exponential function is very close to 0. Okay. Negative values of x is increases, then the exponentially value is close to the 0. Okay. These are some characteristics of the exponential function. In other words, in the second quadrant, the graph approaches x-axis. The exponential function with the base 10 is called the common exponential function. This is called the common exponential function of the base 10 to the power x. Y is equals to 10 to the power x is called as the common exponential function. Okay. Now, it was observed that the sum of the series, always the exponential function can be expressed as, that is, e to the power x. The exponential function always expressed e to the power x is equals to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial up to so on for 1 by n factorial is a number between 2 and 3, and it is denoted by e only. Always the value lies between 2 and 3. The exponential values always lies between 2 and 3. Now, using this the value of e as the base, we obtain the extremely important exponential form, that is y is equals to e to the power x. This is called the natural exponential function. Okay, let's move on the derivative of the e to the power x with respect to x is always d by dx of e to the power x is always e to the power x only. It has the identity. Derivative of d to the power derivative of e to the power x with respect to x is always e to the power x. By using this result, we can solve the problems now. Let I can consider one example, that is differentiate the following with respect to x. Okay, here we can differentiate the problem with respect to x. Now I can consider y is equals to e to the power minus x. Again, they given differentiate with respect to x. Therefore, I am taking differentiate with respect to x, that is dy by dx is equals to, here differentiation of e to the power minus x. In place of x, we have minus x. That's why I'm taking differentiation of minus x. Okay, we know the result, that is differentiation of e to the power x is equals to e to the power x. Here in place of x, we have minus of x. That's why I'm taking again, that is differentiation. Now dy by dx is equals to e to the power minus x. Again differentiation of minus x. I'm taking minus as a common. Differentiation of x will be 1. Therefore, d by dx of minus e to the power x. Okay, this is the differentiation of the e to the power minus x. This is the result of the given function. Okay, let's move on the next one problem. Example number. Here also I am consider sine of log x. That is, I am consider y is equals to sine of log x. Now I can take differentiate with respect to x. Now dy by dx is equals to, here in place we know that differentiation of sin x. Okay, what is the differentiation of sin x? It becomes cos x. Okay, here I can write differentiation of sine, that is cos. In place of x we have log x. That's why I am taking d by dx of that function, that is log x. Okay, dy by dx is equals to, differentiation of sin x will be cos x. In place of x we have log x. That's why I am taking again differentiation. Now dy by dx is equals to cos of log x, and again differentiation of log x will be 1 by x. Therefore dy by dx is equals to cos of log x divided by x. This is the solution of the given problem. Okay, let's move on the next one problem. Question number 3. Okay, that is example number 3. Now again I can consider cos inverse of e to the power x is equals to y is equals to cos inverse of e to the power x. Now taking differentiation, differentiate with respect to x. Okay, now dy by dx is equals to differentiation of cos inverse x. We already know the differentiation of cos inverse x is minus 1 divided by root of 1 minus x square. Okay, here in place of x square we have e to the power x. So I can take e to the power x here to the power square. Okay, in place of x we have e to the power x. So I can again differentiate d by dx of e to the power x. Now dy by dx is equals to minus 1 divided by root of 1 minus e to the power x whole square into e to the power x. Then I can written dy by dx is equals to minus e to the power x divided by root of 1 minus e to the power x whole square. This is the solution of the given problem. Let move on the next one problem. Question number 4. That is, I can consider y is equals to e to the power cos x. Now differentiate with respect to x. Again it becomes dy by dx here. Now differentiation of e to the power x. Differentiation of e to the power x will be e to the power x only. Here we have e to the power cos x. In place of x we have cos x. Now differentiation of e to the power x, that is e to the power x. In place of x we have cos x. That's why I can take again differentiation, that is cos x. Now e to the power cos x, d by dx of cos x will be minus the sin x. Then we want dy by dx. Dy by dx is equals to minus sin x into e to the power cos x. While arranging the terms, we get dy by dx is equals to minus sin x into e to the power cos x. Let's move on the problems. Exercise 5.4. Okay, now we solve the exercise problems. The first one, differentiate the following with respect to x. There is a first one problem here. Now I can consider the given function, that is y is equals to, okay, here I can consider y is equals to e to the power x divided by sine x. Okay, now taking differentiation with respect to x, no, dy by dx. Now we can observe these four terms e to the power x divided by sin x of the form. We can use the u by v form, that is quotient rule. Here I can consider u as the first function, that is u, and sin x as a v. Now what is the formula for u dash divided by v? That is equals to differentiation of u dash into v minus v dash into u divided by v square. Now I can apply here, and that is first I have to differentiate the e to the power x, d by dx of e to the power x. Now then keep it as a constant as sin x, again minus d by dx of second function, that is sin x, again keep it as e to the power x constant, whole divided by what is the v square, that is sin x whole square. V square will be sin x whole square. Now dy by dx is equals to differentiation of e to the power x, again into sin x. Here minus differentiation of sin x will be cos x into e to the power x divided by sin x whole square. Okay, therefore dy by dx is equals to e to the power x sin x minus e to the power x cos x divided by sin x whole square. This is the solution of the given problem. Now let's move on the next one problem, that is differentiation of e to the power sine inverse of x. Again I can consider the equation y is equals to e to the power sine inverse of x. Now differentiating with respect to x, that is dy by dx is equals to differentiation of e to the power x. Here we know that differentiation of e to the power x, okay, e to the power x will be e to the power x. Here in front of x we have sine inverse of x, so I can written e to the power x, that is in place of x we have sine inverse x. Now I can written d by dx of sine inverse of x. Now e to the power sine inverse of x, again differentiation of sine inverse of x, that is that is differentiation of sine inverse of x will be 1 divided by root of 1 minus x square. Okay, this is the solution of the given problem. Dy by dx is equals to e to the power sine inverse of x divided by root of 1 minus x. This is the solution of the given problem. Let's move on the next one problem, that is differentiate with respect to x, that is 3 e to the power x cube. Okay, let's I am consider y is equals to e to the power x cube. Okay, here differentiating with respect to x. Now here dy by dx is equals to, in place of x we have x cube, So first I can differentiate e to the power x. In place of x we have x cube. Therefore I can write x cube. Again in place of x we have x cube. I can again differentiate d by dx of x cube. Now e to the power x cube. Again differentiation of x cube. Already we learned that differentiation of x cube will be, okay, the reducing the power 3 into x square. So I can substitute here 3 into x square. Therefore, dy by dx is equals to 3x square into e to the power square. This is the solution of the given problem. Let's move on the next one problem, that is differentiation of sine of tan inverse e to the power minus x. Now, I can consider the problem here, that is y is equals to sine of tan inverse e to the power x. Now I can differentiate with respect to x. Now dy by dx is equals to differentiation of sine. What is the differentiation of sine function? That is cos. Differentiation of sine function will be cos. In place of x we have tan inverse of e to the power minus x. So I can written tan inverse of e to the power x. So in place of x we have tan inverse. Therefore I can again differentiate, that is tan inverse of e to the power minus x. Again cos of tan inverse of e to the power x. Now differentiate this. Here in place of x we have e to the power x. Now differentiation of tan function, that is 1 divided by 1 plus x square. In place of x we have e to the power minus x whole square. So I can't get x. Therefore I can again differentiate d by dx of e to the power minus x. Let's move cos into tan inverse of e to the power x into 1 divided by 1 plus e to the power minus whole square into differentiation of e to the power x, that is e to the power minus x. Again differentiation of, in place of x we have minus x, so I can again differentiate. Now cos inverse of cos of tan inverse e to the power minus x into 1 divided by 1 plus e to the power minus x whole square into e to the power minus 6 into minus 1. We want dy by dx only. We want dy by dx. Therefore, I am taking minus e to the power minus x into cos of tan inverse e to the power minus x divided by 1 plus e to the power minus x whole square. This is the solution of the given problem. Okay. Now let's move on the next one problem, that is exercise problem 5th one. That is I can written y is equals to log of cosec log of cos of e to the power x. Log of cos of e to the power x. Now I can differentiate with respect to x. I can differentiate with respect to x, that is dy by dx is equals to differentiation of log function. Differentiation of log x will be 1 by x. Okay. Here first I can differentiate log function, that is 1 divided by x. In place of x we have cos into e to the power x. So I can again differentiate d by dx of cos e to the power x. No, 1 divided by cos of e to the power x. Again, differentiation of cos function, differentiation of cos will be minus sine x. In place of x, we have e to the power x. That's why I'm taking again differentiation of e to the power x. Then 1 divided by cos of e to the power x minus of sine e to the power x. Differentiation of e to the power x. Again e to the power x. Now dy by dx will be dy by dx is minus sine x into e to the power x divided by cos of e to the power x. This is the solution of the given problem. Let's move on the next problem. So you can take it as y is equals to e to the power x plus e to the power x square plus up to so on plus of e to the power here that is xn. Okay, here xn. Now I can differentiate with respect to x by each term. Now I can differentiate each term, that is dy by dx is equals to d by dx of e to the power x plus d by dx of e to the power x square plus d by dx of e to the power x cube plus up to so on for d by dx of e to the power x. Now I can differentiate each term. Differentiation of e to the power x, that is e to the power x only, plus differentiation of e to the power x, e to the power x only. In place of x we have x square, so I can again differentiate d by dx of x. Now okay, I can written e to the power x cube. In place of x we have x cube, therefore I can again differentiate, that is differentiation of x cube plus up to so on d by d. Okay, here differentiation of e to the power x. Okay, differentiation of e to the power x to the power n. So differentiation of x, e to the power xn will be e to the power xn. In place of x we have xn. That's why I'm taking differentiation of x to the power n. Now solving e to the power x. Here e to the power x square into 2x plus e to the power x cube into 3x square up to so on for e to the power xn into n x to the power n minus 1. Therefore, dy by dx will be e to the power x plus 2x into e to the power x square e to the power e to the power x square plus 3x square into e to the power x cube up to so on. Then the last term n into x to the power n minus 1 e to the power x. This is the solution of the given problem. Let's move on the next one. Okay, you can solve. Okay, you can solve both 7 and 8 question will be homework for you. Have to solve these 7 and 8 one question. Then you can you upload answer in my comment box. Okay, now let's move on the next one problem. That is question number 9. Then now I can consider y is equals to cos x divided by log x. Again, we have to use the quotient rule, that is UV formula. Now differentiation u dash differentiation v minus v dash u divided by v. U by v whole dash is equal to u dash into v minus v dash into u divided by v. Now I can apply here, that is differentiate with respect to x only. Now dy by dx is equals to, first I can differentiate u function, that is d by dx of cos x, and I can kept log x here minus d by dx of log x. Again I can kept cos x divided by v square, that is log x whole square. Now dy by dx is equals to d by dx of cos x will be minus sin x into log x minus differentiation of log x will be 1 by x into cos x whole divided by log of x whole square. Okay, so this is one of the important important problem for annual exam. Okay, you can write it this much, or you can continue the problem, that is dy by dx is equals to, I can multiply x here, that is x sin x into log x minus cos x. So I can take x on here, that is x, by using the log function, that is log of m to the power n, I can written as n into log of m. Here I am applying the formula, so I can written 2 into log of x. Okay, this is the solution of the given problem. This is also right, and this step is also, both are right. Okay, now let's, question number 10 will be homework for. Okay, this is also one of the homework problem. Now, okay, up to this much, the class will be over. Your comments will help to improve my next class better than this. Please do share, subscribe, and like my channel. Give me an opportunity to share my experience with you all. Thank you, everyone.